So just now on page 3, I mentioned that when they are having 4 coordinate bonds, it is tetrahedral. But sometimes they form square planar. Square planar. Okay? So square planar when it forms. Most nickel and platinum will form square planar. So extra information, group 10 with D8. So that will form square planar shape. So the reason no need to know also, you just need to memorize it. When the exam question asks nickel or platinum, you may try square planar. But the thing is, I come across questions where it is nickel but end up with tetrahedral also. We have that case also, That's why they say most only, not 100% one. Okay, so nickel, try square planar. Okay, reason beyond our syllabus already. So we are not going to care about it. You just need to roughly know about it. So you have 50% chance now, like when they form 4 dative bond, then you can try either tetrahedral or square planar. So nickel platinum, you put square planar, the chance to get it correct is very high. Other than nickel platinum, you put tetrahedral, and the chance to get it correct is very high. Okay, so or you can use periodic table to check, is it group 10 or not. If group 10, then just mention square planar. Now that is the confusing part because they have 2 options, tetrahedral and square planar. Now here, linear. In what situation they form linear? 2 dative bond. 2 dative bond, linear. Okay, so settle for that part. The shape settle already. Now here, 5.10, stereoisomerism. So we have geometric isomerism, which is cis trans. So the cis trans here is different from the cis trans that we learned last time. The cis trans that we learned last time involved double bond, and this one no double bond. Okay, so let's see example. This is cis and this is trans. We have cis on the left and trans on the right. So for cis, right, you can see the ligands of the same type stay on the same side, and another groups of ligands stay on the other side. Trans, you can see they stay opposite from each other, the Cl, and the Mi also stay opposite from each other. So this is platinum, okay, platinum NH3, 2, and Cl2. Okay, so platinum, just now in the note, we already mentioned that platinum is where you have to use square planar. So it's square planar. You see the shape, this is square planar, right? So same one. So it's square planar. And then we have 2 types, cis or trans. And you have to remember, they ask also, in past paper, they ask you to give the usage of cisplatin here. Cisplatin is an anti-cancer drug that acts by binding to DNA in cancer cells, preventing cell division. Cisplatin. How about transplatin? Transplatin is not anti-cancer drug. You see the structure changed a little bit only, but this one is not anti-cancer drug, and this one, yes. Okay, so this is more to pharmacists, so they have to manufacture drug, so they need to know whether the cis works or the trans works. So they have to manufacture accordingly. If you give wrong drug, like Cisplatin, you give to the patient, if you have it can't cure cancer. That is one thing. The second thing is it may causes side effect, like after eating the medicine, then it become blind. That kind of problem. That kind of that kind of side effect. Okay, so let's move on. Next point: optical isomerisms. Optical isomerism. Oh yeah, before optical isomerism, right? The cis trans, right? Cis trans is just for square planar only. Just for square planar only. Square planar, you can see cis trans. Okay. Now, optical isomerism is for what? It's for octahedral shape. Octahedral shape. Okay. So let's see these structures. You see the nickel here have this is the ethylene diamide. The bidentate ligand just now, the bidentate, they have three of them. So two is, the first bidentate is here. They form two dative bond here. The second bidentate is here. They form two dative bond. And the third bidentate is here. They form two dative bond. This arrow should go up. Should go up. Okay, it's an error over there. Okay, should go up. So this is the one of the optical isomer, and this is the other one. So what we can see here is it's like the mirror image. It's like the mirror image. And again, this is different from what we learned last time. Last time, optical isomerism happens when the carbon take four different groups of atoms, four different groups. But this one it's not four different groups. It's not related. It's just three bidentate. You see, example, this one is staying on the right. Now it's staying on the left. This one is staying at northwest direction. Now it stay at northeast direction. This one southeast becomes southwest, something like that, So optical isomerism, settle. Okay, so remember, the cis trans is for square planar. This is for octahedral. Okay, now let's move on. The other side. Okay. 5.11 common complexes. Okay. Now, first we have H2O. Example, CuH2O6 2 plus or COH2O6 2 plus. So when I say this is common, that means what they expect us to remember. So we have to remember their color. Okay, their color. So the color of copper H2O6 2 plus, it is written down here. You can see here, pale blue solution. Pale blue. Okay, pale blue solution for this. So I'm not going to write here because you can always refer down here. And this pale blue solution, right? Okay, is the copper 2 ions in water, normally, or maybe last time when we put Cu2 plus aqueous, we say this is blue color solution. So now in A2, we have to take it like this. Copper 2 ion is actually equivalent to this one. Same one. It's just that last time we never mentioned about the R6H2O that stick to the copper. Now we have to mention it because we learned at a higher level already. It's the same one. So it's the pale blue solution. So we look at their reaction at the same time. So which is here. The copper 2 ions in aqueous you add hydroxide to it. So the hydroxides will go through a reaction here, which is called hydroxide ion remove hydrogen ions from water ligand. So what happened is two of the water ligand here donate hydrogen to it to form H2O, and another H2O here donate one more hydrogen to another hydroxide to form another H2O. Okay, so supposed to have two here, no? Each hydroxide get one hydrogen from the H2O here. Okay, so that means two H2O ligand loses their hydrogen and become OH2, loses hydrogen. And the hydroxide get two hydrogens. Each hydroxide take one hydrogen and form two H2O molecules. So they said this is not ligand exchange. What is ligand exchange? Ligand exchange is like hydroxide go in to become the ligand and then H2O come out. Okay, so that is ligand exchange. It is not ligand exchange. So you have to remember, because the actual reaction is the hydrogen from the ligand is coming out. It's not the hydroxide here going in. It's not. It's hydrogen come out to form water. So it's not ligand exchange. It's not this ligand go in and that ligand come out. It's not that process. It's like neutralization. It's more like neutralization. Okay, so once they form this, then this is pale blue precipitate. Pale blue precipitate. Pale blue precipitate, which is this one. Pale blue precipitate. Okay, so when it comes to copper, when the copper aqueous ion add hydroxide, then something same will happen. They will form this thing. Neutralization happen. The hydrogen from the H2O ligand come out and neutralize the hydroxide. Okay, but the color changes, you have to remember. Initially, this is pink color. Pink color. So I just write down for you. It's pink color. So after that, they form this. What color is this? I can't find out. Okay, I can't find out. So you may Google search it. So I can't find out the color so far. I Google search also. Okay, so it's just pink color. After react with hydroxides, what color? Unknown. Okay, now let's move on. Reaction with ammonia solution. Small amount of ammonia. So you have copper 2 aqueous again. You add a little bit of ammonia, then they will form this again. CuH2O4OH2. Same with this one. Again, this is pale blue precipitate. Okay, so something similar happened. The H2O give away their H, and the NH3 get the H and form NH4 plus. Something similar happened. So initially, ammonia act as a base. They accept the proton, right? And hydrogen ions are pulled off from the hexa-aqua ion as above. So that's from the pale blue precipitate. So the idea is same with this one, Okay. Now, excess ammonia. So if you put extra ammonia, the precipitate just now react with the ammonia, then this is where the ammonia go in already. You can see that ammonia replaces water as a ligand. So this is ligand exchange. Why I have to mention ligand exchange or not ligand exchange? Because exam question like to ask, name the reaction. And so for this case, neutralization. For this case, neutralization. For this case, ligand exchange. Why ligand exchange? Because NH3 go into the complex. You can see here, NH3 is here now. Ligand exchange. OH2 come out. H2O also come out. 2 of the H2O come out. So only 2 remain. So ligand exchange. So this is deep blue solution. So that means when you put a bit of ammonia, it forms precipitate. When you put a lot of ammonia, the precipitate dissolve in water to form deep blue solution. So which is this one? You put a little bit, this is the thing. You put a lot, this is the product. This is the product. Okay. So together with the color, you must remember. Okay. Oh yeah, just now I thought about the color, right? Actually, I know the color. Okay, I just put in a place that is not obvious enough. Okay, I put for you. This is actually green, blue precipitate. Green blue precipitate. So if you put a bit of hydroxide to copper, sorry, not copper, cobalt. CO is cobalt. Then they form green blue precipitate. Likewise, if you put a few drops of ammonia, then they form green blue precipitate. Also, it's the same product. If you put a lot of ammonia, then it dissolves. Now it forms yellow solution. Yellow solution. Okay. So let's see the next reaction. Okay, here. Reaction with chloride ions. So if you take copper 2 ions in aqueous to react with chloride, then they form copper 2 chloride. Copper 2 chloride, green solution. Green solution. So this is the situation, green solution. So if you do it for cobalt, they form blue. Have to memorize a bit. They ask. Just memorize whatever in the notes. Okay? So 6 water molecules replaced by 4 chloride ions. So again, this is ligand exchange. So conclusion, these two are ligand exchange. And these two are neutralization. The color of the product, you have to memorize it.